My name is Raylene Conway, and I'm a biology student at Dalhousie University. This presentation will discuss forest fires through an ecological lens, examining the relationship between forest fires and the carbon cycle, highlighting the impact of anthropomorphic effects, and discussing Indigenous perspectives and philosophies that can be used and implemented to better frame our understanding of our human-centered world in relation to ecology, and in so doing allow for wiser climate change and recovery policies and initiatives. Every living thing relies on the carbon cycle and is an integral part of it. The carbon cycle can be thought of as fast and slow cycles, but the two are intertwined. The slow carbon cycle, which takes millions of years, follows the movement of atmospheric carbon to the lithosphere via precipitation, where the carbon first combines with water to form an acidic compound, which can dissolve rock slowly, a process known as chemical weathering. This releases ions like calcium, potassium, magnesium, and sodium, all of which are necessary for life on Earth. These eventually enter water systems and, in time, enter the oceans. Here, calcium and bicarbonate can form calcium bicarbonate, the main component in crustacean shells and corals. When they die, the shells left behind mix with the sediment of the seafloor, becoming limestone rock. Not all rocks are formed this way. Around 20% are formed from organic carbon embedded in mud, forming sedimentary rocks. In certain cases, layers of organic carbon can also be locked in the Earth's crust as oil, coal, and natural gas. Carbon locked away in stone can eventually be released back into the atmosphere through volcanic eruptions caused by shifts in the Earth's tectonic plates. The ocean is a major component of the carbon cycle, incorporating atmospheric carbon dioxide gas with water, releasing hydrogen. This creates a lower pH and a more acidic ocean. The rate at which the ocean absorbs CO2 is affected by multiple factors, including winds, currents, and temperature. The fast carbon cycle centers around the biosphere, how carbon moves through living things. Phytoplankton and plants can take up carbon dioxide and use it in reaction with water and light energy to create sugars and release oxygen as a byproduct. This carbon can be released in one of four ways. Firstly, these are primary consumers in most food webs, and consumers can break down the sugars for energy, releasing CO2 gas as a product. Secondly, plants can break down the sugars themselves to gain energy to grow and reproduce. Additionally, when plants and phytoplankton decay, bacteria that facilitate this are also releasing carbon back into the atmosphere. And lastly, organic matter can be burned, releasing carbon back to the atmosphere as well. The carbon cycle is regulated by chemistry, and when undisturbed, remains relatively consistent, with predictable highs and lows tied to plant growing seasons and planetary orbital motion, and maintains relatively consistent atmospheric carbon levels. In recent years, however, human activity has thrown off the balance, and as a consequence, we are observing climate shifts, extreme weather phenomena, and more intense, out-of-control wildfires. Fires can be a healthy and, in some cases, necessary part of forest growth, a powerful secondary succession event that is an ecological reset. However, with intense anthropomorphic effects on climate, especially through the carbon cycle, the delicate balance has been wildly thrown off, and fires are now becoming increasingly more intense and devastating. Habitat loss, further increase in atmospheric carbon, and infrastructure destruction are all major concerns. Since the Industrial Revolution, shifts in the carbon cycle can be seen due to human activity. The burning of fossil fuels releases trapped carbon at a rate much faster than it can be reabsorbed by the Earth, causing a drastic increase in carbon and other greenhouse gases in the atmosphere. This increases the net radiative forcing of our atmosphere, increasing the temperature of the Earth. This temperature shift does increase the amount of CO2 that the ocean can reclaim, but not enough for it to balance our use and release of CO2. And the increasing temperature of our atmosphere also increases the maximum amount of water vapor, another greenhouse gas, that it can hold, further increasing the temperature. These human-centered causes of temperature shift have a myriad of effects, including more intense weather phenomena and drier forests, more vulnerable to extreme wildfires, like the ones we've been seeing in recent years. These extreme wildfires release massive amounts of CO2 back into the atmosphere, creating a positive feedback loop. Higher temperatures, meaning more extreme fires, meaning even higher temperatures. Climate change is one of the most critical issues of the 21st century. Climate change, mitigation, and recovery policies and programs are at the heart of this. Indigenous principles, like two-eyed seeing, which aims to bring together Western and Indigenous ways of thinking, are a good way to frame these discussions and obtain wise solutions. One of these is the 7 generations principle, which offers a framework to put decisions into perspective by looking to the future with the wisdom gained from the past. One example of this Indigenous Western partnership is the Blue-Green Planet Project, a nature-based sustainability initiative that partners with many of Canada's Indigenous communities and forestry professionals. I had the opportunity to work with them to replant forests that were destroyed during wildfires as part of a recovery program. The audio clip brought back memories of smoky skies and blocked-out sun from the ongoing wildfires near where we worked, and the ashy aftermath of the fires in the burn blocks that we were planting.